three triangles for this one. Let me see if you have enough to draw your three real quick. Okay.
Because, let's see. Because the small one, you only have the one length on the left side for the, I guess, the longer leg. Or no, it'll still be a short one. And then the second one, you have the X and the 35, then X and 42. If I did that right. But I think I did. But
have X. And then I think you're right. Let's see. You don't know the short. 42. And the long leg is X. Yeah. Is this what you had?
yes. Although I turned them sideways, but
yeah, it's fine. As long as you had like all three hypotenuses the same, the short legs the same, the long legs like I have. All right. So then this one's not helpful at all. Doesn't have much information.
I think I might have drawn the last one wrong. I think I switched the X and the 42 on accident.
Gotcha.
Oh, okay. I see what I did.
Yeah, the X's of the biggest triangle. The X is the long leg.
Right. Because the 42 continues all the way down. Yeah, this would actually be something that I could use, but
yeah, if you set them up this way, then you would say these two pieces are corresponding, and then these two pieces are corresponding.
Which would still give you the X squared.
It would.
Plus the 1470.
Yep.
Okay. All right. Awesome. That helps a lot. And then there was another question that, like, I understood what they were saying. It was just very vague. It was talking about a string hanging from a rope being, I think, 7 feet from the ground and the pole being 13 feet. And they wanted you to find, like, how long, I think, the distance that the rope was.
Don't you all see that?
Yeah, I got it right. I could sort of see they were asking me to make a triangle out of it, and I was just trying really hard to draw a picture. It just didn't work.
All right, let's see. Something about a string. Saw one about a cable and a plant. That wasn't the one, huh?
Oh, yeah, that was actually going to be another one of my questions, but either one's fine.
Okay. Let's see. Photographer. Yep, that's a camera. Sorry, I'm flipping through.
It's okay.
A fishing pole? No, top of a pole to the ground. Yeah.
Yes,
Okay,
yes.
that's it. I don't know why I saw fishing pole.
Oh, puppy.
Puppy.
I want a puppy.
All right. 13-foot pole, 7 foot in base. Okay, so we have a pole. It's 13. And a string from the top to a point on the ground that's 7 feet from the base. So here's our string. 7 foot from the base. Is that what you got?
No, I did not draw it like that, no. I didn't think, because I thought when it just said hanging from the pole, it'd be hanging straight down.
Gotcha.
I wasn't really thinking in terms of math, so.
Yeah.
I see how that is now.
To a point on the ground 7 foot from the base. That's
and it's just Pythagorean theorem.
Yeah.
Gotcha. That's what I ended up doing from process of elimination, just because I knew how to get it. Just my picture wasn't really working out. I wanted to make sure that was more or less the way to get it done.
Yep, that's it.
And I think, pretty sure this is my last question, but the one about the cables and the plants.
Okay, let me find that one.
I will again.
If you don't think that's the cutest thing. All right. Okay, plant is braced by 3 cables attached to the collars, traveling 8 feet up the trunk. Each cable is staked to the ground 3 feet from the trunk. All right, so I'm just going to draw one of them. So here's the trunk. That's 8 foot. And it's attached 3 foot from the trunk. And there's the cable, right? Are you trying to find how long the cables are? I cut off that part of the question.
Yeah, there's like 2 parts, one part above and one part underneath the plants. The Pythagorean part where you just find the side length, I understood.
Yeah.
But the part, what was the second part of the question? Because I think that was...
If a fastening cable to the collar uses 8 inches of cable and a fastening to its stake uses 8, how much cable has been used?
Yeah, that's the part that I did not get.
Oh, gotcha. Let's see. Let me look at the cable thing. So I guess it's saying like right here is 8 foot, like wound up or something.
Gotcha.
Or either these fasteners down here, maybe. You know how like when you tie down a rope, you have to tie a little extra around the thing. I guess that's what it's. Let's see.
Was it not 8 inches rather than 8 feet?
Is it? I'm flipping back and forth because I cut off that part. I was like, yes, it is 8 inches. That would make a big difference.
Yeah.
Thanks.
Like all I did was take 8 inches, that's twice, divide it by 12, I believe, to see how many feet that was and just add it on.
That'll work.
Yeah. Gotcha.
Okay.
Cool.
So whatever you get at the end, whatever you get for your hypotenuse, add the 8 inches and the 8 inches. 8 inches for the top and 8 for the bottom. That should be.
Okay. That's like...
You have to remember to multiply it all by 3.
Oh, is it asking you total for all the cables
You
together?
You want to have all cables.
Oh, yeah. How much cable has been used? So that would be 3 cables.
Gotcha. Okay, that's like a lot easier.
Good.
Okay. I think I just overthought it, like, and that's why I had the problem.
Yeah. The next time you're going to brace your freshly planted sapling, you're going to need to know. So.
Oh yeah, just have the whole line of those waiting up for me.
All right. Other questions? Anybody?
I don't think so.
No, you're good.
I believe so.
All right.
I was looking at one and I wanted to make sure I did it right. Let me find it. There it is. So it's talking about, I'm finding like the altitude of an equilateral triangle.
Mm-hmm.
So slow, it makes us 30, 60, 90. That's okay. Never mind.
Are you sure?
Yeah. I mean, we can go over it just in case, but I think I figured it out because it's an equilateral triangle. And if we find the altitude, we would split the top angle in half, which it's an equilateral triangle. That would make it 35. And then you'd have 60 and then 90 as your 3 angles of your right triangle.
Yeah. Because here's a equilateral / equiangular. I didn't pull up the problem. I was just going by what you were saying. And then, yep, if you draw that altitude, both of them would be right triangles, and it's splitting this in half. So this becomes 30. My pen would write. And this one's still 60. So, yeah.
Okay. That makes much more sense. Because I like worked it out the long way and got the same answer, but I was like, that took way too long. Because like I divided it in half, found out that the shorter leg was 5 and the hypotenuse was 10, and then I ran those through Pythagorean theorem, and then I had a radical that I had to simplify, and then I ended up getting 5√3. But once I worked all that out, it was really easy because I had 5√3 for my altitude. Then I looked at it and I was like, wait, I could have literally just run this 30, 60, 90.
Yeah, I like proofs. I told you there's always different routes to get there. Some are just a little more quick than others.
Yeah.
Is it the equilateral with side lengths of 10? Is that it?
Yeah.
Okay. So you got it?
I did.
Okay. Other ones? Other questions?
No, I think I'm good for now.
Good for now.
More than halfway done.
Good. If there's anything to, like, if y'all missed something on a quiz or something that we were doing yesterday, or you're just, sorry, bud, anything you're just flipping through the chapter and you're a little fuzzy on it, we can go over something.
Ooh, I actually do have one. So it says a photographer shines a camera light at a particular painting, forming an angle of 40 degrees with the camera platform.
Okay. Yeah, I remember seeing that. Let me find it in my order of questions. They reorder them, so I'm not sure what number it is. Hang on. Photographer. Okay, got it. Let me.
Oh, bite.
I can have a bite. Thank you. Okay.
Mom, what back?
Yeah.
Yeah, that's it.
That back?
58 feet from the wall. How high above the platform is the painting? So you're looking for this side here, right?
Yeah. So I'd
So
probably set it up through tangent.
Tangent. Okay. Yeah. From the 40, the X is your opposite. And the 58 is your adjacent. So tangent was the right choice. So did you do tangent 40 equals X over 58?
Yeah. And then you would move the, well, you're trying to get X on its own, so you get tangent 40 over 58 equals X.
Yes.
Right?
Did you say 38? Be careful, it's 58 in the picture.
I thought I said 58.
Okay, it is 58. All right. So that's all you would need to push was in your calculator, because you get rid of that 58. This is what we were doing a minute ago. You're trying to get rid of that 58 denominator. So on the right side, it'll get rid of it. So this is what you punch in the calculator.
Ooh.
Let's see. Let me get my bigger calculator. 58 times. What'd you get?
48.66777.861, which would.
There you go. You got it.
7. Got it. Sweet.
See, I just remembered there's one more thing I had a question about. I'm just trying to find the right example in the book.
Okay.
Oh, here it is. It's when it asks to find the perimeter of a triangle, and it gives you like one angle and then one side.
Oh, okay.
So, because I thought I had it right, but I think I got like one part of it wrong. Because I don't know how to find a side length with an angle.
With the trig functions.
Oh, that's it? Okay. I thought trig was just for the angles, though.
Inverse trig is for the angles. What page are you looking at? And I'll get there.
464, question number 25.
464, 25. Let me get. Let's see. Yeah. It's going to be a multi-step problem because you're going to have to find those missing sides before you can find the perimeter. That's right. What makes it a little bit different.
So if you used, even though there are no variables for the hypotenuse and the longer leg, can I put one there Because I guess I could use, what would that be? So I'm using 31. I could do no. Yeah, I guess I could do sine for the hypotenuse.
Yeah, make that your variable first.
So would that be 6 sine of 31?
Let's see. Sine.
That can't be right. I got 3 something.
Sine 31. Oh, sorry, I just got hit in the face with a half-eaten apple. Sine 31 equals opposite over hypotenuse. So 6 over x. All right, this one's different. And this is the reason I say writing out the equation is sometimes helpful to know where your x and where your 6 are. So since it's opposite over hypotenuse, it'd be 6 over x. So then in your fraction, you want to get rid of the x, right?
Right.
So your x's would cancel. X times sine 31, that doesn't help you.
No.
So you want to get x by itself. Sine 31. My writing's getting worse by the second. Sine 31, you want it to go away over there because you want x by itself. Does that make sense?
Yes.
So then if you did that on the left, you're going to need to say on the right, 6 over sine 31. So in this one, you have to divide.
Gotcha.
Sometimes you divide, sometimes you multiply. It depends on where your variable is in your equation.
So would you plug that into the calculator, just 6 divided by the sine of 31?
Mm-hmm.
Oh, okay.
What'd you get?
All right. That I got 11.649 or 11.65.
Mm-hmm.
Which sounds about right.
So you get that as your hypotenuse. Then to get your other leg, you can use trig again.
I could use
Pythagorean.
Yeah, okay. I could use Pythagorean. That's right. If I were to use trig, I would.
Go ahead. No, you go ahead.
Okay. One second. I'm trying to determine which trig function would suit that. Yep. So you could use. Or actually, because you're only given the one angle measurement. So
I'm going to put another variable there. We'll say y is that leg. So what trig function would you need if you were trying to find y? Forget about the x that we found. Just if this was a new problem, you were starting from scratch, and you had that 31 and the 6, how would you find your y?
That'd be opposite over adjacent. So that would be the tangent, sorry.
So this time tangent 31, opposite over adjacent, so 6 over y. So this looks like the last one. I mean, a different trig function, but with the variable denominator, right?
So you'd have to divide again.
Correct. But this time you're hitting a different button because you're hitting the tangent, so you're going to get a different answer.
Gotcha. So I got a 9.985, which could round to 9.99.
Mm-hmm.
Okay. All right, awesome, yeah. And then what if I'm looking for the angle measurements after I have found those side lengths? That's when you would use the inverse of the angle.
Number 25, if the instruction said solve the right triangle, then you'd be almost finished because you found the 2 missing sides. You just have to find the other angle.
Oh, I can just use the process of elimination.
Yeah, you can just subtract.
Gotcha.
The ones where you have to use reverse trig, let me get one of those real quick. It's inverse. I say reverse because you're kind of working in reverse. But
gotcha.
Oh, I went too far. Sorry. I know you can't see what I'm doing, but I'm flipping pages and I went too far in my pages. Sorry.
It's fine. Okay. Yeah, I think for me, I actually learned how to identify the problem I need to solve. Because sometimes I look at it and just overthink it, and make it way harder than it needs to be.
Mm-hmm.
So.
Yeah. Read the instructions twice if you need to.
Right.
Make sure that you're not working harder than necessary. All right. I'm going to just grab one where there's missing angles. It's number 15 on page 480, but I'm going to put it on the screen too. So.
I have a question. Are we going to be able to have our right rules for right triangles sheet?
No, not for the test. But you have your spiral, which has got most everything in there. And I'll tell you a little secret that those rules are really kind of like the section titles. It's kind of what they are, with just very little differentiation. All right. So 15, this one, you know 2 of the sides and you know the right angle. In the instructions that I cut off, it says solve the right triangle. So when you solve a right triangle, you find all the sides, all the angles. So to find side HJ, what would you do? What's the quickest way?
Well, I mean, you use a Pythagorean theorem for the other leg.
Exactly. So that would be the quickest way to get HJ. So remember the biggest one, the longest side, the hypotenuse by itself. And then the other 2 together.
Should be 7.745 or 7.75.
7.75, you said?
Yes.
Okay. All right. So there's your other leg, and then you got to find the angles. To find the angles, you choose a place to start. It doesn't matter which one you find first. You just make your choice. So I'm going to say G. And I don't remember which day you're absent or which day you're there, but in class I said, I know this numbers, it's just fine, and it'll get you an answer, but working with that decimal that you've already rounded kind of like cheapens the answer every time you round again. So use your whole numbers. So from angle G, what part of the triangle do you know? Like opposite adjacent, hypotenuse, those kind of parts.
Well, you know the adjacent and hypotenuse.
So which trig function is that?
Cosine.
So you're going to say cosine of angle G that we don't know equals adjacent over hypotenuse. Does that setup make sense?
Yes.
All right. From here, it really is just calculator, but you have to know how to punch it in the calculator.
That's have to do the second and then cosine, right?
You're exactly right. Anytime you're looking for your angle, that's your clue that it's that little -1 thing, the inverse.
Gotcha. I got 28.95 or 29, I guess that would round to, for the measure of angle G.
You're right. 28.95.
Gotcha. Okay. And when we do this, should we be rounding or just leave it as the decimal?
The instructions that on that page, I think it said, round decimal answers to the nearest tenth. That's how it usually works. So that one, because it's 9.5, technically it'd just be 29 because you're rounding up from that 9. Does that make sense how to get G?
Awesome.
To get J, you can do inverse trig again. Or
you can do the same thing.
Yeah.
Or
go ahead.
I'm just kind of thinking through it kind of out loud. I guess with J, would 14 technically be the opposite angle to J? Or opposite side length?
Yes.
So then you have opposite over adjacent, so that'd be a tangent.
No, not opposite over adjacent. Be careful.
But that'd be the hypotenuse, my bad.
Yeah, don't use the decimal. Yeah. You can do opposite over adjacent, but it'd throw that decimal in there. So it'd be the
sine.
Sine for J is opposite over hypotenuse. And this is your clue to use the inverse.
Gotcha.
Why?
61.044. I guess we can say 61.0. So
correct, 61.
Got it. Awesome. Okay, that's very straightforward.
Yeah, good. What I was going to say is once you find one of the angles, like we found the 29, then you can either use inverse trig again like we did in the green, or you know that those two smaller angles have to add up to 90. So if this one's 29, you know you need 61 more so that those two will add up to 90.
Gotcha.
Or that's a way to check yourself. If you do the inverse trig and you got like, I don't know, 71, then you know, wait a second, 29 and 71, that's too much.
Gotcha. Awesome. That helps a lot. Thank you.
Good.
Question. For the chapter title, are you looking for where it says right angles and trigonometry?
Oh, you're talking about the right rule thing?
Yeah.
No, I'm talking about
looking for taking my screenshot.
Oh, yeah. Sorry.
It doesn't like say that. It's like
I just took a picture with my phone. It kind of like took the whole screen, if that helps.
Yeah, let's see. Submit. I just stunk it up. So I'll show you. I'll grab. Y'all are gonna be really proud of my score. I did so great.
Yeah.
Let's see. So show me. I'm very grateful, by the way. The school gave me a laptop that's great for Math Lab. Show me that you can see that in your picture.
Okay. Whoa, nice score.
I know, right?
Phenomenal. I didn't do super hot on that myself, so.
I think you got at least 5 more right than I did.
Same.
Well, for real, y'all can do these tests. I mean, I know it's not like what you want to spend your whole day doing, but I do want y'all to be prepared. You can do them more than once. So these interactive ones,
Yeah, I mean,
it just resets. Every time after you do it, you can redo it.
Okay. Awesome.
And you can also, if there's like one section you're rusty on, like if the inverse trig is just really tough for you, you can just go to the, let me get back to the website. You can go to under the resources under each lesson, and there's a quiz just for that lesson. And like the one for 7.7, it only has 2 questions. So it'll keep reloading questions, and you can just try those kinds of questions if you're just rough on 1 or 2 sections.
Gotcha. Well, thanks for your help.
You're welcome. Other questions? I know Christian was still there. Janie?
My question was from like a long time ago in the lesson.
That's fine.
7.3 practice B.
Okay. Let me pull that one up. So give me 1 second.
It was the one like with the geometric mean theorems.
Gotcha. Okay. 7.3B. What, buddy? Let me share the right screen with you just a second. You're okay, Cruz. I pulled it up. Oh, I was trying to pull up an old version. Sorry. Hang on just a second. I didn't notice that. Create a new. There we go. Sorry, switching to a worksheet just takes an extra minute. It's fine. It's just, sorry for the delay.
Oh, that's fine.
Okay, can you see it now?
Mm-hmm.
Are you talking about these like 13, 14, 15?
Yes.
Okay.
I couldn't figure out for 14 BD.
Okay. 14, you are going to use the geometric mean, but you actually can use the Pythagorean first, so that you could find, let me get my pen, so you can find this piece first, and then that way you'll know part of the hypotenuse.
I think I got 2 for that AC.
2?
Mm-hmm.
So let's see. I don't remember what it was. You know what? I'll just scroll down real quick. 14 AC. Practice B. Yes. All right. That was the first step. So you're good on that. All right. Then if you're going to get BD, you have to know about, it's a roundabout way. I have a very roundabout way in my head. Let me see if there's a faster route to tell you. Oh, okay. All right. I see two different ways, and I'm just going to go with one. But if it doesn't make sense, we'll try the other, okay?
Okay.
All right. So AB is a leg. So if you know a leg and you know something about the hypotenuse, you can figure out the rest of the hypotenuse. So I'm going to put an X on this other piece of the hypotenuse for right now.
Okay.
Because the leg theorem says that the leg is the geometric mean, so that's what's repeated, between the whole hypotenuse, which if I put that X there, the whole hypotenuse would be X plus 2, because you put the pieces together, and the piece of the hypotenuse that touches that leg. So if I'm using root 10, the piece that touches it is 2. Does that setup make sense?
What apple here?
Thank you.
Could you
Here.
get like root
You
6
will pay her.
2
Oh, what?
over root 6?
Here.
Yes, you can, to find that other piece. Yes.
Okay.
Like I said, there's like 3 different ways to look at it. And I went with the first one my brain told me. So, but yeah, there's, you want to do it that way instead?
Either way works.
That way it might be, I'll go with what your brain's telling you. So it's root 6. This would be the altitude, geometric mean altitude theorem. So root 6 is the altitude. It's the mean between the two pieces, 2 and x. So then cross multiply, 2x equals 6. X is just 3. I'm going to scribble this and put a 3 right there. From this point, you can do the geometric mean leg theorem to find BD, or you can do Pythagorean, because now you know this whole side, and you can find the third side, BD, that you're looking for using Pythagorean.
How would you use the theorem with the root 10? I think that's what confused me.
Okay, this pink that I wrote.
Oh, yes. Like, how would you square it with the others?
Oh, gotcha. How the Pythagorean theorem with the root 10? Is that what you mean? I'm sorry. Math lab's awesome, but sometimes you gotta see that alligator. Okay, so Pythagorean theorem, you know, is hypotenuse squared. So now we know that whole thing is 5. Let me 5 squared equals leg squared, so root 10 squared plus, I'll just say BD squared, because that's the other leg of the triangle. Are you with me on that? Okay. 25. When you square a square root, the number just comes out, because technically that's root 10 times root 10, which is the square root of 100, which is 10, right? So one way to remember it is when you square a square root, it kind of gives that number a buddy, so it gets to come out. So then from there, follow, subtract. So BD is not 2. Kind of looks like it's pointing to the 2, sorry. Root 15. Did you follow? Did I lose you? Did I not answer what you were asking at all? Let me know.
I think I understand.
Okay. If you, let's see. 15, were you okay?
15, I didn't get either one.
Okay. Let me erase the writing that's on top of 15. Let me look at that one. Okay. And this, my worksheet overlaps. I think, was that 35? Does your worksheet look different than mine?
No, they look the same.
That overlapping number?
Oh, it says it's square root of 35.
Okay, yeah. I don't know why. I guess this program just does something funky on that number. Root 35. All right. All right, for this one, you know about a leg and you know about part of the hypotenuse. That leads you to the geometric mean leg theorem in order to find out more about the hypotenuse, or you can do the altitude theorem to find the altitude first. Which would you prefer?
I think the altitude one makes more
Okay.
sense.
All right, so that would help us find BD. So I'm going to make BD our X. Not altitude theorem. Yes, we will use altitude theorem, but first we have to find the altitude. So if you look at the medium-sized triangle, you know two of the sides because you have root 35 and 5. How can you find X or the length of BD?
The Pythagorean theorem.
So that's kind of like what we were doing down here with this root 10 thing. How would you set it up?
The square root of 5, or no. What's it called? 5 root 2. That was called. Plus, x squared equals the square root of 35 squared.
X squared plus 5 squared, is that what you said? Okay. I think at one point you said 5 root 2, and so I was like,
I think that's what I said too.
I was like, how'd you get 5 root 2? I was trying to think where it came from. Okay. Yes. X squared plus 5 squared would equal, hang on, buddy, would equal root 35 squared. Just be careful when you're doing the ones about whether it's acute, right, or obtuse to put the hypotenuse on the other side, but it's fine. So x squared plus 25. What is the square root of 35 squared?
35.
Yeah. So then x squared would be 10. So x is just root 10. I kept going because that's the algebra of it, but if I lost you somewhere, let me know.
No, I'm good.
Okay, so now we know that the altitude is the square root of 10. And that was just Pythagorean. Now to find AC. AC in this triangle is the whole hypotenuse, and we know part of it, but we need to figure out that other little piece that we're missing. So we're going to use the altitude theorem. I'll use a different variable since I already used x. I'll make this y, okay? We're trying to find that so that we can know the whole hypotenuse.
Okay.
So the altitude theorem says that the altitude is the geometric mean. So the altitude is going to be repeated between the whole hypotenuse. What's the whole hypotenuse of the big triangle?
5y.
Plus y.
Oh.
be careful. Think about it because, like, if y, well, y is a number, we just don't know. If y was 1, then the whole hypotenuse would be 6, right?
Mm-hmm.
You'd be adding them together. So 5 plus y is the whole hypotenuse. And then in the other spot, your numerator, that is, okay. I'm so sorry. I got distracted by my kid talking about Batman. I was doing the leg theorem. I was doing altitude, then halfway through switched over. Scratch that, but rewind. Okay, the altitude is the geometric mean between the two pieces that it cuts, because the altitude cuts them.
So it would be 5 and y.
Yes, I'm sorry. I started setting up the leg theorem midway through. All right. So there is your setup. What would you do when you cross multiply?
5y equals the square root of 100.
Which is?
10.
Yeah. So then the easiest algebra problem ever, right? Y equals 2. Because you just divide by 5.
That makes a lot more sense now.
Excellent. That's the goal. Except when I start the problem incorrectly halfway through. So that's dA, that little piece. But remember, you're trying to find AC. So how much is AC?
7.
Yeah. Do you feel a little better about those? You still rusty on those?
I think I'm still a little rusty, but it makes a lot more sense now.
Good. Let's see. I can look in the book and see if there's another one with the mean that we could practice. Let's see. I did that thing where it kicks me out of the book. Just a second. Let me get back. If you have a minute, I have a minute to do another one. If you need to go, it's okay, but I can do another one if you want. Do you have a minute?
I do.
Okay. All right. This is the first one I see, so I'm just going to grab this one and go with it. All right. This is just one of the examples from that lesson, but in the example, they show you how to do it, drawing the 3 triangles, but we'll talk about how to do it with the mean theorem. So you're looking for y, and you know about the parts of the hypotenuse. Y is a leg in the biggest triangle, which tells you the leg theorem is what you're trying for. So far, so good?
Yes.
Okay, so with the leg theorem, geometric mean, leg theorem, the leg is the geometric mean. So what's going to be repeated in this proportion?
Y.
Y. Between the whole hypotenuse.
So 9.
This one they tried to make it kind of straightforward. And the piece of the hypotenuse that touches that leg.
So 3.
I know these are easy numbers, but I think it kind of helps you visualize what goes where when numbers are a little easier. So the leg is the geometric mean between the whole hypotenuse and the piece that touches the leg. that make sense?
Mm-hmm.
Okay, so then you just cross multiply to solve it. Y squared is 27. And this one, it wanted the radical form. So you do your little factoring. What would this one be?
3 root 3.
Yes. I know that one's easy. Would you rather have a harder one or?
Are they going to be like that easy on the test?
They may not be as straightforward. Let's see. Let's get one from the homework section. I was just trying to grab the first. Let's see. Those are easy. All right, this one's a little challenging. We'll do this one and then you're silly, Chris. Okay. This one you have to use a couple steps in it. So let's see. It's coming. All right, can you see it?
Which number is it?
This is number 23 in that lesson 7.3. Let's see. It's on page 448. Number 23.
Okay.
Am I sharing the right thing on my screen? It's not sharing the right thing, is it? You can't see number 23? Let me reshare. Sorry. Okay, now can you see it?
Yes, I can.
Okay. Sorry, I thought that's what it was showing you. All right, so this one, you're trying to solve for all these variables, so you have to do a combination of different things. First, look at x. How would you solve for x? Which mean theorem could you use to get x?
The altitude.
How would it be set up?
12 over x equals 16 over 12.
You got it. Does that make sense? Yes, no, kind of, sort of.
It does.
Okay, so whatever. 144 divided by 16. Did you get 9?
Yes.
Okay, now I realize that you could use Pythagorean to find the other ones that are missing now. Because if you look at each of the smaller triangles, like the really tiny one, you have 12 and 9, you could use Pythagorean. The other small triangle, you could use 12 and 16 and find it. But just so we can practice the leg theorem, we're not going to do it that way in case there's one where you don't have all that information. Is that okay? Okay. So, do you want to try to find y or z?
We can do y.
Okay. So if you're finding y, that's a leg, so you know you need the leg theorem. And when you're using the leg theorem, the leg is the geometric mean between the whole hypotenuse and the piece of the hypotenuse that touches that leg. So how would we set up our proportion?
Y over 25 equals y over 9.
So close.
Or 9 over y.
There you go. Does that make sense? There you go. So whatever that is, y squared equals 25 times 9 and take the square root. So 15. Is that a little less fuzzy, I guess, on the mean theorems?
Yes, I think I got the hang of it now.
Good. And like I was telling Christian or Will, one of them, if you go to the student resources, you can go to lesson 3, and there's an interactive quiz there just for that section.
Oh, okay.
And let's see how many. It's only got 2 questions, but you can, do it again and again, and it'll repopulate different questions to help you practice.
Okay.
That would be immediate feedback, so you know if you're getting it or not. So.
Right.
All right. Well, if you think of something else later, you can email, and I'll be glad to answer.
Okay. Thank you very much.
You're welcome. Have a good day.
You too.
Thanks.